Hi guys, this is day 10 of the A2 Economics Revision Challenge, and today we are doing the national income determination with open economy. In a four-sector model now, we are looking at AE to be equal to C plus I plus G plus X minus M, which means we are introducing X minus M, or the foreign sector. So when you introduce foreign sector, we're looking at exports, which is basically resulting in what we call an inflow of money in the economy. Also, sometimes we call it injections, and imports, which are resulting in what we call outflows or withdrawals in the economy. So now when we introduce our our four sector model, we're looking at open economy with government. So this is where our model will complete, because we are introducing the four sector model. Now in our model, when you look at exports, where is this exports coming from? And the answer is this exports is basically demanded by foreigners. If it's demanded by foreigners, we say this, that our income can go up when there is more exports, but our income going up cannot affect our exports. In other words, exports, we say, is also autonomous in our model. Autonomous means not dependent on our Y or income. So our income can go up or down, but our income going up and down doesn't affect the foreign country's GDP. In fact, foreign countries' GDP goes up, that can result in our exports to go up, because they can demand more of our exports. So in our model, basically the first thing we need to know is this, that exports is autonomous, which is not a function of Y, not dependent on Y. On the other hand, when we look at our imports, on the other hand, imports, we say, is basically demanded by local sort of consumers, and that basically is a function of Y, or not autonomous but induced. Why is that induced? Well, simply because if income go up, one could argue this, that people can buy more of a good. So in our model, let's assume X to be equal to 540, which is a constant, which is not a function of Y, and let's assume imports M to be 0.25 Y, which means if I give you $1, 25% of that dollar will end up being consumed in imports. So we are looking at export to be autonomous and import to be induced. Now, before I move on to talk about our AE function, I just want to talk about one quick thing which comes a lot in MCQs, which is that if X minus M is greater than 0, this means that more exports are coming in than as far as imports are coming. This is what we call sometimes a current account surplus, but it is also what we call net injections, the money coming into the economy then going out. So the trade flows are positive and therefore net injection. Similarly, if X minus M is less than 0, we call it a current account. It could be a current account deficit, although current account has other sections as well, but I'm looking at it only X minus M right now, and we call it a net withdrawal. Money is going out, then coming in. So one thing we need to remember is that if X minus M is less than 0, we're running a deficit, but that also means that your current account is, your net withdrawals are taking place. So now we move on to our four sector model, where now AE becomes equal to C plus I plus G plus X minus M. And I'm going to write my C. C is now 100 plus 0.72Y. This is, of course, after adjusting for taxation. Our I is equal to 250. G was 170, as we remember from our last model. Now I have X, which is equal to 540, and M, which is equal to 0.25 Y. So now I have C plus I plus G plus X minus M. Now I want to write other things as well, because remember this, that A is equal to C plus I plus G plus X c plus I plus g plus x plus minus m, but we also have w equation where w is equal to s plus t previously. Now we'll add one more withdrawal, which is m. And similarly, injection is I plus g plus x. So we have these as injections. So now our model is complete, where withdrawals are s plus t plus m and j is I plus g plus x. So in equilibrium, we know this A must equal y. That's one equation. And the second equation that we need to remember is that w must equal j. So let's use this to find out our equilibrium income, and also then use this to find out our multiplier. So when we put the values of AE, so AE becomes equal to C plus I plus G plus X minus M, which means 100 plus 0.72Y plus 250 plus 170 plus 540 minus 0.25Y. This is my C plus I. So AE becomes equal to 1080 plus 0.47y. So our A equation is 0.47y. A equation equals 1080 plus 0.47y. And now I can also find out my W equation, which is simply S plus T plus M. My W equation will be basically minus 100 plus 0.18y plus T is 0.1y and M is 0.25y. So if I add all this, my W equation will come out to be minus 100 plus 0.53y. So I'm going to save that as well, because I'm going to make sure W is equal to J. And last working that we'll do is to make sure we find ourselves J, which is simply I plus G plus X, which is your 250 plus G is 170 plus X is 540, which means J is equal to 540 plus 170 plus 250 is 960. So now with these results, I can look at my equilibrium income and my multiplier. So let's draw the diagram for this. First, we'll draw our A is equal to Y line. That's our equilibrium income. So A is equal to Y looks like this. It's a 45-degree line. And then I'll draw my A function, the current A function, which is A is equal to, we found out 1060 plus 0.543y. And it's meeting at this point Y star. Now this Y star corresponds to this Y star here as well, where my withdrawal function must meet my injection function, something like this. And I get my self injection to be 960, withdrawal to be minus 100 plus 0.53y. So wherever W is equal to J happens, that's when A is equal to Y in the upper diagram. So what's my equilibrium income? Well, to find equilibrium income, A is equal to Y, or 1060 plus 0.43 y is equal to y, or 0.75 y is equal to 1060, and because I took y on the other side, 0.43 y on the other side, so y minus 0.43 is 0.57, which means my equilibrium income will be 1060 over 0.57, which is an exact 2000. So my y is 2000 here, and that same answer, I don't need to sort of prove it, should come here as well, which is 2000. Now we need to talk about how do we get ourselves the multiplier in the fourth sector. So the multiplier in the fourth sector, multiplier is equal to again 1 over 1 minus MPC, which means 1 over MPS plus MPT plus MPM, because now we have three withdrawals that are happening, which is your saving, taxation and imports. So the working of that would be 1 over 0. MPS is 0.18 plus 0.1 plus 0.25, which is equal to 1 over, and the number would come out to be 0.53, which is equal to 1.82. So my multiplier in this case will be 1.82. Now, the thing that we need to remember, and that's an important lesson for us, is that in a two-sector model, my multiplier was basically 1 over MPW, 1 over marginal propensity to withdraw, because the withdrawal was only saving, I'm going to write this, then it's 1 over MPS. Similarly, in a three-sector model, again the formula is 1 over MPW, which means again 1 over MPS plus MPT, because now in a three-sector model I have two withdrawals, which is saving and taxation. So I have, in a three-sector model I have two withdrawals. In a two-sector model I have one withdrawal, while in a four-sector model my withdrawal is equal to 1 over MPS plus MPT plus MPM, which means now I have more withdrawal happening. So this is something which you need to understand, this, that once you move from a two-sector model to a four-sector model, the multiplier values will change. In fact, the multiplier will become smaller and smaller as we move from 2 to 3 to 4 sector, and the reason is very simple, primarily because more withdrawals mean more smaller multiplier.